Hi guys, today we are going to see probability exercise 15b. This is from S Aggarwal, question 1. So we have 25 cards. The total number of outcomes is equal to 25. The first part of question is we have to find what is the probability of getting a number divisible by 2 or 3. So let's first do for divisible by 2. So multiples of 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So these are the numbers which are divisible by 2. Next, let's see what are divisible by 3. So multiples of 3 here. 3, 6, 9, 12, 15, 18, 21, 24. So up till 25, these are the options, counts, possible outcomes. So total possible outcome which are divisible by 2 or 3 is going to be 16. Here if you see 6, 12, 18, 24 are repeated in both sets. So we have to take only count of ones. So only from one set. So the possible outcomes is going to be 16. And the total outcomes we already know is 25. So probability of getting a number divisible by 2 or 3 is equal to 16 by 25. Possible counts by total outcomes. Possible outcomes by total outcomes. Second part of the question 1 is, what is the probability of getting prime numbers in the list of 25? So we know prime numbers are only divisible by itself. A number divisible by itself. 2, 3, 5, 7, 11, 13, 17, 19, and 23. So these are the prime numbers. And the count is going to be possible outcomes is equal to 9. So the probability of getting prime numbers is equal to 9 by 25. Next question number 2. So we have a cards in a box. The cards are 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27, 29, 31, 33, 35, 37. So all are odd numbers from 3 to 37. So total number of outcomes is equal to, if you count, it's going to be 18 cards. So we're going to find what are the cards with prime number over here. That's going to be 3, 5, 7, 9, 11, 13, 17, 19, 23, 29, 31, and 37. So these are the cards with prime number. The prime number already we have discussed, one which is divisible on by itself and one only. So probability of getting prime number is equal to, so the possible outcomes are listed above. So that's going to be 11 by, total outcomes we know 18, so 11 by 18 is a probability. Next question, number 3. Total number of cards is 1 to 30. So that's going to be making a count of 30. Total outcomes equal to 30. And the first part of the question is not divisible by 3. So we are going to find what are the numbers not divisible by 3. So to find that, we should know what are the numbers divisible by 3. We know all the multiples of 3. So 3, 6, 9 goes up till 30. The multiples of 3, those are divisible by 3. So we need to exclude those from the total count. So those numbers are only 10 in count. Total minus multiples of 3. We will get 30 minus 10 equal to 20. So 20 numbers are not divisible by 3. Probability of getting a number not divisible by 3 is equal to 20 by 30. Further simplifying it, we get 2 by 3. Second part of question is prime numbers greater than 7. From the total outcomes, we need to list them out. So which are prime numbers not greater than 7. So 11, 13, 17, 19, 23, 29 are the numbers greater than 7, and they are prime as well. So the probability of getting prime numbers greater than 7 is equal to, possible outcomes are 6. So 6 by total is 30 is equal to, we can further simplify this, 1 by 5. Next is third part of this question. Which of those numbers are perfect squares? So we know perfect squares is 1, 4, 9, 16 and 25, because up till 30 we have that much. 36 cannot be part of this. So there are 5. So probability of getting a perfect square and the listed number from the total outcomes is going to be 5. So we are going to see what is the probability of getting not a perfect square. So by subtracting the perfect square from the total, we get this value. So 30 minus 5 is equal to 25 numbers. So the remaining 25 numbers are not a perfect squares. So probability of getting not a perfect square is 25 by 30. If you want to find probability of a perfect square, then it's going to be 5 by 30, the other way. So for the simplifying this, we get 5 by 6. Question 4. Numbers from 1 to 35. If you see the pattern, it's an odd number. So in general, we know that what is the for arithmetic progression formula. If you see an equal to a plus n minus 1 into d. So here an is the last term and a is the first term, d is the difference between the terms. So an last number over here is 35. Last term an represents last term, and here the last term is 35. And we know the first term a is 1, and the difference between each is 2. 1 and 3 is 2. The difference between 3 and 5 is again 2. So d is 2. So by substituting this values, we'll find the value of n. So 35 minus 1 equal to, or 34. So 35 minus 1 is 34 equal to 2n minus 2. So we get the value of n (18), because 34 plus 2, that minus 2 comes to the other side, becomes 36. 36 by 2 is going to be 18. The total number of cards in a bag is 18. Now we have to find the probability of getting a prime number. We are going to find probability of getting a prime number less than 15. That's going to be, we know it's an odd number pattern, and 1 is not listed here, and 1 is not a prime number again. 2 is a prime number, but it's not part of this list. So 3, 5, 7, 11, 13 are the list of prime numbers from the total outcomes. So the probability is 5 by 18. Second part is a number divisible by 3 and 5 from this list. That's going to be only two numbers, probably 15 and 30. So probability of getting a number divisible by 3 and 5 is equal to 2 by 18. Further simplifying, we get 1 by 9. Next, question 5. So box contains card from 6 to 70. And we know the arithmetic progression formally here. So the last term is 70 and the first term is 6, and the difference is going to be 1. So we have to substitute the same. 70 equal to 6 plus n minus 1 into 1. So 70 minus 6 is going to be 64 equal to n minus 1. So n equal to minus 1 goes the other side. It's going to become 65. So first part of the question is, how many one-digit numbers are here from 6 to 70? That's going to be 6, 7, 8 and 9 only. So probability of getting one-digit number is going to be 4 by 64. Sorry, 4 by 65. Second part is a number divisible by 5. So number divisible by 5 here are all the multiples of 5. That's going to be 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. So probability of getting a number divisible by 5, that's going to be 13 by 65. By further simplifying, we get 1 by 5. Next, third part of the question. Odd numbers less than 30. So odd numbers starts from 7 here, since the starting list is 6. So 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27 and 29. So probability of getting odd numbers less than 30 is equal to, so the possible outcomes are listed above by total. So 12 by 65. Next, fourth part of the question. A composite number. So what is a composite number? A number has more than, the factors more than itself and 1. The simplest example is number 4. So 4 is divisible by 4, 1, and also 2 into 2 makes 4. So 1, 2, 4 are the factors of 4. So 4 is a composite number. So we are going to find all the composite numbers between 50 and 70. That's going to be 51, 52, 54, 55, 56, 57, 58, 60, 62, 63, 64, 65, 66, 68, and 69. Since between is given, 50 and 70 to be excluded from this list. So probability of getting a composite number between 50 and 70. Possible outcomes are listed above. So by the total, that's 15 by 65. Further simplifying, we get 3 by 13. Next, question number 6. So cards are in the pattern of 1, 3, 5 up till 101. So we know the last term is 101, first term is 1, the difference is 2 over here. So by substituting all these values in the arithmetic progression, we get the value of n. So the 1 go other side, it becomes 102. So value of n equal to 51. So first part of the question is numbers less than 19. That's going to be 1, 3, 5, 7, 9, 11, 13, 15, and 17. So these are the possible outcomes. So probability of getting a number less than 19, that's going to be 9 by 51. Next, second part of the question is prime number less than 20. So we need to list them out. That's going to be 3, 5, 11, 13, 17, and 19. So the probability of getting a prime number less than 20 is equal to 6 by 51. Next, question number 7. Total number of tickets is 2, 3. It starts that way and up till 101. So we know total number of tickets is going to be 100 since it starts from number 2. So here the even numbers can be 100 divided by 2. That's going to be 50. We can do by arithmetic progression formula also, or directly as well. So probability of getting an even number is equal to 50 by 100. So further simplifying, we'll get 1 by 2. Number less than 16, we are going to find for the second part of it. That's going to be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So probability of getting a number less than 16 is equal to 14 by 100. Further simplifying, we get 7 by 50. Third part of the question. The second one is not listed out properly in numbering list, so we're changing that. Let's get fine now. Yeah, third part of the question is, a number is a perfect square. So what are the numbers possible perfect squares here? 1, it's not starting from 1, so 2, so 4, 9, 16, 25, 36, 49, 64, 81, and 100. So probability of getting a perfect square equal to, the possible outcomes are listed above, and the total we know for its square is 100, so 9 by 100. Fourth part of the question, prime numbers less than 40. So what are those? We need to list them out. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37. So probability of getting a prime number less than 40 is equal to 12 by 100. Further simplifying, we get 3 by 25. Next question, number 8. Box contains 80 disc. We need to find what are the perfect squares in that. So 1, 4, 9, 16, 25, 36, 49, 64 will be listed here. So these are the possible perfect squares within the list of 1 to 80. So probability of getting a perfect square equal to 8 by 80. So for the simplifying, we get 1 by 10. Next question 9, if you see, in a piggy bank we contain 100 50 paise coins, 70 1 rupee coins, 50 2 rupee coins, and 30 5 rupee coins. So total coins in piggy bank, we need to add all those counts. 100 plus 70 plus 50 plus 30, that's going to be 250. So probability of getting 1 rupee coins, we know 70 is the 1 rupee coins count. So 70 by total is 250. 7 by 25. This is the first part of the question 9, and second part of it is probability of getting not 5 rupee. So we just need to subtract how many 5 rupee coins from the total. We get that as an answer for this. So 250 minus 5 rupees, we know 30. So 220. So probability of getting not 5 rupee coin is equal to 220 by 250. That's going to be 22 by 25. Next, third part of the question. Probability of getting 50 paise or 2 rupee coins. So we need to add both the options, how many 50 paise and how many 2 rupees. So that will be the possible outcomes for this. 100 plus 50, that's 150. So probability of 50 paise or 2 rupees is 150 by 250. That's going to be 3 by 5. Next question 10. Total number of balls in a jar we don't know. So let's assume it as X. There are only 3 colors balls. So probability of getting red balls is mentioned over there of 1 by 4 in the question itself. Probability of getting a blue ball is equal to 1 by 3. And they have mentioned there are 10 orange balls. So probability of getting an orange ball, that's going to be 10 by X, as we do not know the total number of balls in the jar. So 10 by X. And we also know the total, all the possible outcomes is equal to 1. So 1 by 4 plus 1 by 3 plus 10 by X is equal to 1. So by taking LCM, 4 3s are 12, 12x is the denominator. So 3x plus 4x plus 120 by 12x equal to 1. Seven x plus 120 equal to 12x. 12x goes to the other side. So 120 equal to 12 minus 7. That's going to be 5x. So x equal to 24. So therefore, number of balls in the jar is 24. Hope this is useful. If you find this useful, please do share and subscribe. Thank you.